student ID 1242520. I'm from group KSB and this is my submission for Excel assignment. So first we look at the question. For question 1, calculate the amount of monthly installment. So the first thing we need to do is we list all the information we have. So the information we have here is, first we have principal of 300,000, period of 30 years, repayment period of 6 months, interest rate of 4.5%. So for first step, we need to find the monthly interest rate, which is J. So we calculate using the J formula, which is 1 plus I over power of 1 over 12 minus 1. 1 over 12 because it is monthly interest rate. So we get 0.0036740809. So for in the question, it mentioned that interest only paid is 36 months. So in 36 months, they only pay interest only. So total months in 30 years is 360. So minus with the interest only period, we have 324. So to find the balance at month 6, we multiply the principal with the 1 plus J power of 6. So we get the balance at month 6. So interest payment, we multiply the J with the balance at month 6. So we get the interest payment. And the monthly installment, we use the formula PMT. Then we put the value rate of J, period of remaining amortization, and then we multiply the principal and the with the monthly interest rate, power of 3 and power of 6. So we get the value 1620 and 0.83. So question 2, construct the loan amortization schedule to show the financing arrangement. So this is my loan amortization schedule. I have one column, payment, principal paid, interest paid, and outstanding balance. So for the month, just +1 for every row. And then for the payment, we use formula if month less or equal 6, which is the payment period, it's 0, or if it's more than 6, then we use the formula if again. So if month is less than or equal to 36, which is interest only payment, so the payment on is the outstanding balance, the previous outstanding balance, multiply with the monthly interest rate. If not, we use the formula mean to find the minimum value. If the monthly installment is higher, so it will take the another value, which is the previous outstanding balance plus the interest paid. So here are the result. We will stop at the 360 because the minimum value of this is smaller than this value. So it will get this, it will we will take this value. Okay. For the principal paid, we just calculate with payment minus with the interest paid, and then the interest paid we just calculate with the previous outstanding balance multiply with the J, which is monthly interest rate. And here we log here, because if we don't log here, the value will go down continuously, so we need to log here. So we get this result. For the outstanding balance, we just minus the minus the previous outstanding balance with the principal paid. So we get this result, and it will stop at 360. So next question is evaluate and find the minimum possible financial term that can be achieved through this strategy, which is the extra payment. So for the extra payment, we have the extra payment maximum is 10%. The frequency is 12. The start is year 2, and the month start is 1. So to calculate it, it's actually simple. Just we just add the extra payment column, and then don't forget to change the formula of principal paid, which is payment minus interest paid. But here we add extra payment, so payment plus extra payment minus with the principal paid. So for the extra payment formula, we use if formula. If okay, to make sure the outstanding balance doesn't come with the negative value, so we use this formula. So if the outstanding balance is 0, so it will become 0. So if not, we use if formula. And is like if the two value here is correct, so it's true. So first one, we have if month is more than or equal 13, because the frequency start with 12, or and the mod here, if month plus minus 1 divided with 12 equals to 0, so it's the 10% multiply with the previous outstanding balance. If not, it's 0. So the result will be like this. So with the extra payment, it will stop at 146 here. So it will jimatkan masa selama 360 tolak ni 230 34, yes, 234 month. So next to the question 2. So for the question 2, we need to calculate the internal rate of return, calculate the net present value, determine the present value payback period at which discounted cash inflow full recover the additional present value, and based on my answer, which project should the corporation choose? So for the question 2, we have project seri year-end cash flow and the Bakavali year-end cash flow. So first before we start, we find the present value of the project seri and cumulative value of the project seri, and the present value and the cumulative value for project Bakavali. So for the present value here, we use formula year-end cash flow, which is here, divided by 1 plus rate of return, which is 4.5%, power of A5, power of month, power of year, sorry. So we get this value, and then for the cumulative value, we just add the previous cumulative value plus with the present value, so we get this value. So same goes with the Bakavali project, we just use the same formula, and then we get this value. Then to find the IRR and NPV for both project, we use the formula IRR, and then I just use the whole column because I do not put anything below this value. Same goes with the Bakavali, just use IRR and then the whole column, we get this value. And then for NPV, we use MPV, and then we put the rate of return first, and then we put whole column. Same goes with the Bakavali, so we get this value. And then for the payback period, we use the mesh formula. Next we use index, and then mesh index, so we get this value. Okay, from the answer that I did, I think the project Bakavali is the winner. In conclusion, although the project seri is marginally higher net present value compared to project Bakavali, project Bakavali is the more viable capital investment decision. This selection is justified by project Bakavali superior internal rate of return relative to project series, as well as its significantly shorter discounted payback period of 30.4 years versus 16.16 years. So that's all for me. Thank you.